Okay, so let's just finish this up. So I've got 0, 1, and keep it an E. Need 2, and I need to keep it in E. I need 3, and I need to keep it in come on. Keep it in E. And 4. And keep it in E. All right, so finally done. So 2 zeros, 6 ones, 13 twos, 8 threes, 1 4. The majority falling at about 50-50 13, which you kind of expect that to happen since you got 50% chance of heads, 50% chance of tails. It should end up 2 and 2, and 13 times it did happen that way. So that's typical. Again, the program I used, it was rand between, and then I just started using count ifs. But rand between can work for A, B, C, or D. So instead of 1 and 2, you could go rand between 1 and 4, and that would represent A, B, C, or D. You can do that for a variety of different things. So yeah, that's the rand between. You don't need it on the test or anything, but just so you know, Excel does use or does do experimental probability. Okay, so back to the original questions here. Flip a coin 4 times. We did that, and we did it 30 times in simulation to represent the whole class. All right, next question. Roll a die 6 times. Record the number of 6s you obtain. Combine the results of the whole class. So again, rand between 1, 6, and then you just count the 6s. You got to roll a die 6 times, so you'd want to repeat the rand between 6 times across. And in the 7th column, you just do count if. And count if it's a 6. And that'll be your total. And then you can compile it. So there is count if and rand between for simulating experimental probability. Homework 14, numbers 1 to 4, 6 to 10, 12, and 14. And there's the experimental. Now let's get into some of the theoretical, the meat and potatoes of this unit. Theoretical probability of an event is based on calculations rather than conducting the experiment. So just determine the theoretical of the following. Obtaining a head. Well, there's only one head divided by all possible. Well, there's 2. So 1 out of 2. Rolling a 4 in a single roll of a die. There's only 1 4 out of all possible. And there are 6 possibilities, so 1 out of 6. Picking a prime number from 1 to 10. So you want to count up your prime numbers, only divisible by itself, and divided by total possible is 10. You've got 2, you got 3, you got 5, and you got 7. 1 is not a prime number. So your total is 4 out of 10 or 2 out of 5. Getting into more complicated. Well, before we get there, let's get the general formula. If the possible outcomes are likely, or equally likely, then N of A is the number of times A can happen. So the probability of event A happening is the number of ways A can happen divided by all possible events. Probability of drawing each of the following from a standard deck of cards. So slightly more difficult. Remember, there's 52 cards in a deck. A 7, there are 4 7s. out of 52. A red card. There are 26 red cards, half of the deck. So 26 out of 52, or lowest terms 1 out of 2. And a spade is 13 out of 52, or a spade is one of the 4 suits. So it's 1 out of 4 lowest terms. Venn diagrams. You can use a Venn diagram to visualize. So same process for the Venn diagrams. Fill in from the middle out. Divisible by 3. So we've got a circle in the middle representing divisible by 3. We put all the numbers that are divisible by 3 inside that circle, and every other number goes outside the circle. And that might help visualize it. Looks like there are 6 numbers inside the circle, 20 total numbers, lowest terms 3 out of 10. Many board games involve 2 6-sided die. We've talked about how to deal with 2 6-sided die. You need to make your diagram on the right hand side or left hand side or wherever you want, but your diagram with 1 to 6 across the top, 1 to 6 along the side, and figure out. So the probability of rolling a total of 7. So make your diagram and look for the number of 7s. Taking a look at this diagram, we have 1, 2, 3, 4, 5, 6 7s. 6 out of 36. Six 7s out of 36 total. 6 times 6, 36. Lowest terms 1 out of 6. Your probability of rolling a 7 is 1 out of 6. We did this very early in this second half of the semester, but probability trees could also be helpful if you wanted to visualize. Determine the probability of obtaining 2 heads when 2 coins are flipped. So you can make your probability tree of heads and tails, and then the second one, heads and tails. There's your probability tree. The probability of obtaining 2 heads is 1 out of, and remember, the total is the last column. So there's 4 in the last column. That means 1 out of 4. Heads, heads happens once out of the 4. Almost done now. Jacob is getting dressed this morning. He has a pair of khaki pants and blue pants. For the top, he has golf shirt in blue, white, and red. Creating the probability tree. You can deal khaki pants or blue pants. And then second column, golf shirt in blue, white, or red. Dogs are going crazy. All right, so the probability tree is done. Jacob doesn't want his shirt to match his pants. What is the probability that he's happy with his choice? So there really is only one instance where he wouldn't be happy. And 5 out of 6 he would be happy. So the BB is the only time that he would not be happy. The other 5 are good, so 5 out of 6 he's happy. Remember complement. The indirect method, essentially, where instead of going direct at what you want, you could look at the event not happening, and that's the complement. And that can be useful in probability as well. So all the previous counting technique tricks or techniques that we showed you, you can continue to use those in probability. Whichever outcome makes up A, all other outcomes make up a complement or not A. So the complement is just not it. Because A, that's the event you want, and complement A not, or A complement, because those two things cover all possibilities, they have to add up to 1.0 or 100% of the time. So you can use the idea of 1 minus to solve problems. Essentially, event you want and event and all other events. So event you want is event A, and all other possibilities is not A. The combination of that has to add up to 100%. Now, if you want just not A, that is going to equal 1 minus event A, or probability of event A, I should say. So 1.0 or 100% of the time minus the probability of A happening equals not A happening. And the reverse is also true. Probability of A equals 1 minus probability of not A. So you can use the indirect method. Just remember the two have to add up to 100% or 1.0. So you can do 1 minus one of them to get the other one. What's the probability that a randomly drawn integer between 1 and 40 is not a perfect square? Probably easier to get perfect squares. Easier to determine the number which are perfect squares. Perfect squares, 1, 4, 9, 16, 25, 36. There are 6 out of the 40. So if it's 6 out of 40 that are perfect squares, how many are not perfect squares is 1 minus 6 out of 40. Lowest term, 17 out of 20. So I just did 1 minus the event I didn't want. That gives me the event I did want. All right. Questions in textbook, page 24, 1, 4, 5AC, or A2C, 6, 7, 10, 12, and 16.